Welcome back. So let us continue our discussion on evaluating the performance of any algorithm. So in the last session we discussed about space complexity. Let us see what is time complexity and how to evaluate the time complexity for various algorithms. So time complexity is evaluated as the time taken by an algorithm. So how do you evaluate the time complexity? The general method is, we know that a program is typed, compiled and then executed. Normally the compile time, so we know that the compile time does not depend on the algorithm. So it depends on it depends on the characteristics of the configuration of the machine. But once a program is compiled, it can be run several times on different data sets. So if you want to assess the performance of an algorithm, it is essential to evaluate accurately the amount of time taken by the algorithm. So we need not include the compilation time. So if you look at this, in simple words, the time complexity taken by a program is the sum of the compile time and the runtime. But as I said earlier, compile time does not depend on the inputs. So by instance characteristics we mean the number of inputs and the outputs. So a compiled program can be run several times without recompilation. So if you want to assess the performance of any algorithm, it is enough if we analyze the runtime. So how do we calculate the runtime? So the runtime is denoted by, let us assume the runtime is denoted by TP. That depends on the instance characteristics. So if the characteristics of the compiler are known, we could determine the number of additions, subtractions, multiplications, etc., and the time taken for one addition. So in that case, you can compute the time complexity by adding the number of additions in the algorithm multiplied by the time taken for one addition. So likewise, say CA into add of n. Add of n is the number of additions in the given algorithm. CA is the time taken for one addition. Likewise, we add the number of additions multiplied by time, number of subtractions, number of multiplications and number of divisions. So totally we get the time complexity. But obtaining an exact formula is an impossible task. Why? Because the execution time of an algorithm does not depend only on the number of additions, subtractions, etc. But it depends on several other factors. What are they? So in a multi-user system, for example, the execution time depends on number of other programs running on the computer. So that may increase the time taken for one arithmetic operation. Similarly, the characteristics of other programs running in a multi-user environment. So it is difficult to compute the time complexity just knowing the computation time for addition, subtraction, etc., because it is affected by other factors in a multi-user environment. So in that case, we define a parameter, that is program step. So a program step is defined as a syntactically meaningful segment of a program that has an execution time independent of the instance characteristics. So we define the program step as a syntactically meaningful segment of a program that has an execution time independent of the instance characteristics. As I said earlier, instance characteristics means the number of inputs and outputs. Let us see how to compute the program step. Say we all know that a program contains assignment statement, control statement, command statement, conditional statements. So step count, we assign a step count for each type of statement. For example, assignment statement is given a step count of 1. Control part of a for loop may be given a step count as 1. Comment statement, if statement 1. Comment statements, they don't contribute to the execution, so we assign a step count of 0. Likewise, we assign a step count to each statement, executable statement. The total time complexity is computed as the sum of the step counts for every instruction in the algorithm. You will understand if we discuss with an example. Say for example, finding the sum of n numbers. Algorithm sum s is equal to, we initialize the sum variable. You could see we have introduced or we have inserted a count statement, a count variable. So we initialize a count variable, and each time a statement is executed, we increment the count by 1. Say in this case, s is equal to 0.0, it's an assignment statement, so we increment the count by 1. Next statement, for I is equal to 1 to n, so it is a for statement, looping statement. The control part of the for loop is assigned the step count 1, so we increment the count by 1, count is equal to count plus 1. Similarly, we have the next assignment statement, s is equal to s plus a of I. We add the first element in the array. And then we have statements 11 and 12. So statement 11 is meant for the last execution of the for statement. We all know that the control part of the for loop will be executed n plus 1 times. All the statements inside the for loop will be executed n times, but the last execution we check whether the value of I has reached the value of I is greater than n. So there is one last execution of for. So we increment the count by 1 for the last execution of our statement. And then finally, for return statement, we assign a count 1. So that we insert before return itself, because the control will be returned back. So we insert the count statement before statement 13, return yes. So what will be the time complexity of this algorithm will be the sum of, will be the value of the count variable at the end, after completion of the algorithm. So if you retain only the count statements, you could see count will be incremented twice inside the for loop and outside by 3. So for loop will be executed n times, so 2n. And outside the for loop, count will be incremented by 3, so the time complexity of iterative sum algorithm will be 2n plus 3. So this is step count method. Count is a global variable. We initialize to 0 at the beginning of the program, and then after every statement we increment the count variable by 1. So finally the value of count variable will give you the time complexity of any algorithm. So we have seen an example. We can see one more example, that is recursive sum. How to calculate the time complexity for recursive sum. So here recursive sum, count is equal to count plus 1 for the if statement. If n is less than or equal to 0, then, so here we are implementing 1. And then within the if loop, we are incrementing the count by 1 for the return statement, return 0. If n is less than or equal to 0, the control will be terminated, the program will be terminated. Otherwise, we increment the count by 1. So this increment of count variable is for the return statement. So this will be repeated for every recursive call. So how do you compute the time complexity for this recursive algorithm? You could see for each call. So when the value of n is equal to 0, if n is equal to 0, the time complexity will be equal to 2. Because for the if statement we increment the count by 1, and for return statement we increment the count by 1. So it will be 2. Otherwise, it will be 2 plus, again the call will be recursively calling the algorithm with n minus 1 as the parameter. So if n is greater than 0, it will be 2 plus t of recursive sum of n minus 1. Hope you understand how we compute the time complexity for a recursive algorithm. So if you, by substitution method, this recursive sum, we can compute the time complexity by substituting for TR sum of n minus 1. You could see that TR sum of n minus 1 is expanded to 2 plus TR sum of n minus 2. So now it 2 times 2 plus TR sum of n minus 2. Likewise, if the value of, if you have reached n, this recursion is called n times, then it will be n times 2 plus recursive sum of 0. Why 0? Because it will be n minus n, that becomes 0. When the value becomes, when the recursive algorithm is called n times, then here finally the value will be 0. So what is recursive sum of 0? If value of n is equal to 0, it is 2. So the time complexity of this recursive sum algorithm will be equal to 2n plus 2. So this is how we calculate for recursive algorithm. There is a second method where you use step table method. Here is another example for matrix addition. So you know matrix addition, we have two nested loops I and j. So the input matrices A and B are added and the result is stored in C. So how to compute the time complexity for matrix addition? So we insert count statement after every statement in the algorithm. So for I is equal to 1 to m, count is incremented by 1. Similarly for j is equal to 1 to n, we are incrementing the count by 1. And for addition of matrices, we are this assignment statement, we are incrementing the count by 1 in statement 10. So statement 12 is the last execution of j loop, and statement 14 is for the last execution of I loop. So totally the time complexity of this matrix addition will be, if you retain only the count statements, the algorithm will look like this. So line 5 will be executed 2n times, because it is line 5 is inside the I loop, so it will be 2m times. It's outside the j loop and inside the m loop, so it is 2 into m. And line 7, it's inside both the loops j and I, so it will be 2 into m into n. So line 7 will be executed 2 into m into n times. And then line 9 will be executed only once, because it's the last execution of I loop. So the total count will be 2m, 2mn plus 2m plus 1. So it's this is how we compute the time complexity. The second method is step table method. So we follow the similar procedure, but instead of using the count variable, we use a table, a step table. So that step table will record the steps per execution of the statement and the number of times, the frequency of each statement. If you just look at the table for the same iterative sum, you have 4 columns: statement, steps per execution, frequency, and total steps. So algorithm statement, it's just a null statement, and then s is equal to 0.0. Steps per execution will be 1. How many times it is executed? Its frequency is also 1. So multiply the steps per execution, and the frequency, you get this total steps. Similarly, the control part of for loop, for I is equal to 1 to n. Steps per execution is 1, and its frequency, how many times statement 4 is executed, is n plus 1 times. So frequency is n plus 1. So 1 into n plus 1, the total number of steps will be equal to n plus 1. Similarly, for step 5, the steps per execution is 1. How many times it is executed? Because it's inside the for loop, for I is equal to 1 to n, so it will be executed n times. So the total number of steps will be equal to n. Return statement, it's only 1 and it will be executed once 1. So if we add up all the total steps, we get 2n plus 3. So this is the second method. We call it a step table method for computing the time complexity. So likewise, time complexity for adding two matrices. So for I is equal to 1 to n, for I loop will be executed m plus 1 times. So 1 into m plus 1, m plus 1. For j is equal to 1 to n, statement 4 will be executed m into n plus 1 times, because it is nested inside I loop. So m into n plus 1. And then the addition statement, addition of two matrices, statement 5 will be executed. It is inside both of I and j loops, so mn. So the total value will be 2mn plus 2m plus 1. So during this session, we discussed how to compute the time complexity. We follow two methods, count variable method and step table method. Count variable method uses a global variable count, and then for every execution statement, count variable is incremented by 1. So the value of the count variable at the end will be the time complexity. The second method is using a step table. So we use a table for recording the steps per execution, frequency and the total steps. Finally, the total value will give you the time complexity. Hope you understood today's topic. Bye for now. Thank you.